Hello, my name is Mariana Vallejo, and I am a PhD student and project assistant at the Department of Geography and Regional Research at the University of Vienna. In this video, I will talk about mapping tools for capturing SoftGIS data, how data is collected and categorized, what mapping tools are often used, and how can we select the appropriate mapping tool. The SOFT methodology developed at Aalto University in Finland was designed to connect two key concepts: the soft knowledge that people contribute, such as opinion, feelings, and experiences, and the hard analytical tool of Geographic Information Systems, or GIS. In simple terms, SoftGIS is an online framework that collects, analyzes, and shares localized, subjective insights from people. This approach integrates people's everyday experiences and knowledge into spatial planning and decision-making. What makes SoftGIS unique is its focus on how people interact with their surroundings, how they perceive them, and how they feel about them. This type of soft spatial data is mainly collected through geo-questionnaires. A geo-questionnaire usually has two parts. First, the mapping activity, where participants add points, lines, or polygons onto a base map to highlight specific locations or areas. Then, a follow-up questionnaire, which collects more details about those places or areas, often through multiple choice or open-ended questions. If you would like to learn more about geo-questionnaires, please check the video on our channel about digital sketch maps. In SoftGIS, the information collected through geo-questionnaires is typically grouped in four main categories of subjective data. The first, patterns of spatial behavior, showing how people actually use spaces. For example, identifying the streets most commonly used for commuting, the areas where people cycle, or the parts where residents spend free time. This helps planners understand daily mobility and recreational needs. Second, values and valuable places, highlighting locations that are meaningful or significant. For instance, marking community gardens or areas with ecological and cultural importance. These insights support strategies for preservation and community development. The third, experiences and subjective evaluations, capturing how people feel in particular places. For example, pointing out areas where residents feel unsafe at night, public places where they feel socially connected, or streets where litter and noise negatively affect their experience. This information can guide improvements in safety, design, accessibility, and overall urban quality. The last, development preferences, expressing people's ideas for the future. For example, suggesting new green corridors, safer pedestrian routes, or better public transport connections. These preferences provide valuable input for shaping future urban and regional plans. Geo-questionnaires employ different mapping tools that allow participants to highlight places or areas on a map. The most common is the use of points or markers, where users simply click on the map to add a point or drag and drop a marker onto a location. Sometimes, however, the data needs to be represented more explicitly, showing the extent of the highlighted area. For this, several tools can be used to collect aerial data. Here I will go through four tools: the polygon tool, the marker tool, the spraycan tool, and the XMapper. Let's see them in detail. Polygon tool is the most common method, also familiar from GIS software and web maps. User creates polygons by clicking vertex by vertex on the map to define the shape. Once the polygon is completed, it can be edited by dragging, adding, or deleting vertices. The marker is a freehand drawing tool. This works like drawing with a marker on a paper. Users can scribble directly on the map, and the line thickness automatically adjusts to the zoom level. At close zoom levels, the line becomes finer, allowing more detailed drawing. The Spray Can tool offers an alternative to polygons when areas have fuzzy or indistinct boundaries. Like the spray paint, it highlights zones with gradually transitions. The spray radius adapts to the zoom level, producing a concentrated spray when zoom in and a wider spread when zoom out. The X-Mapper tool overlays an hexagonal grid on the map, which adjusts dynamically with the zoom level. At higher zooms, the grid becomes finer, allowing more precise selections. Users can select or deselect individual hexagons with a simple click, making it easy to define custom areas. Now the question is, how can we select the appropriate mapping tool? Let's take a look at this comparison table. Polygon tool is best for precise and well-defined boundaries, useful for mapping the outline of a park or highlight few city blocks. It allows detailed editing of vertices, making it ideal for studies that require accuracy. Marker tool is suitable for sketching larger areas quickly or making routes and paths. For example, it can represent daily jogging paths or an area within a forest, without requiring exact boundaries. The Spray Can tool is designed to represent areas with indistinct or fuzzy boundaries. It works well to show transition between spaces, such as gradual changes in land use or areas perceived as noisy. It can also represent intensity, since dense spray highlights stronger perceptions. The X-Mapper tool simplifies selection by allowing participants to click on hexagonal cells. This is especially useful for showing clusters or patterns across a space, such as areas of frequent crime reports or concentration of recreational activities. It supports comparison at different scales because the grid adapts to zoom levels. The choice of a tool should be guided by methodological considerations, not only by the characteristics of the tools. For instance, the objectives of the study, the spatial scale, the intended purposes, and the desired level of detail or generalization. In conclusion, there is no single best map tool. Each one serves different purposes depending on the research goals and the characteristics of the data we want to collect. Thank you for watching the video on mapping tools for capturing SoftGIS data. If you want to know more about the topic and the work we do in the Digital Geography Working Group, please read the description below.